We're back again for the second E-Day. This one's going to be an extension of the same stuff that you did last time on redox. I just want to review a couple things before we do what we're going to do today. Most important is right there, Leo-Gur. Leo-Gur again means lose electrons oxidation, gain electrons reduction. The number one goal that we're going to try to do today is if you look at a balanced chemical equation, a lot of times elements gain or lose electrons as they form new bonds or break bonds. We want to be able to figure out who is losing electrons, therefore the ones that are oxidized, and who's gaining electrons, the ones that are reduced. Now, same issue as last time. We're still struggling on trying to get a way to write. So all I'm going to have is my mouse today, but on the other power, there's another video that you can watch on YouTube. There's a link to it on Learn. He's got the ability to write. Now, just to warn you, when you watch his, he's going to say oil rig, O-I-L-R-I-G, instead of Leo-Gur. It's the same thing. O-I-L means oxidation is losing electrons, or you can say rig, which is reduction, is gaining electrons. But I tend to use Leo-Gur, just so you know. Real quick review. These are those rules for assigning oxidation numbers, and we still have to know how to do that. If you already turned in your e-assignment for this the last one, and you were struggling a little bit on how to do oxidation numbers, you need to make sure you go talk to your teacher, because that hasn't gone anywhere. We still have to know how to do that. It's really important for what we're about to do. So here we go. Basically, a redox reaction is any time electrons are gaining, or anytime elements are gaining or losing electrons. So how are we going to figure out who's oxidized, who's reduced, and whether or not it's even a redox reaction in the first place? Well, the first thing you have to do is the stuff we did last time, which is give everybody their oxidation states. So you have to be able to go through, look at each of those individual elements, figure out, hey, this is hydrogen, so it's +1. Oh, this is oxygen. Oh, I know that's -2. Hey, this is a group 1A element. That's +1. Group 2A element. That's +2, and so on, and figure out everybody's charges. Then you have to use Leo-Gur or oil rig to figure out who's gaining and who is losing electrons. The last final thing is that the element that it was oxidized, and I know they do this on the final a lot of times at the end of the year, but they will say, okay, who's the reducing agent? Well, look, whoever was oxidized had to be the one who reduced the other thing. So whoever's oxidized is the reducing agent, and whoever was reduced is the oxidizing agent. So we're going to do some examples. Now, if I were you, I would pause this video right now, and I would write down that balanced equation. All right? Because it's going to be very hard for you to see what's going on if you don't have it written down. Again, all you're going to see from me is the mouse moving and hearing me talk. So I can't really write it out. You'll need to write it out, and hopefully, write it correctly, and then I will walk you through who's oxidized and reduced. For this first one, we're going to go across here, and we're going to give everybody their charge. We need to know iron's charge. We need to know copper's charge, sulfate, oxygen, or sulfur and oxygen, and so on, all the way across. Then we're going to figure out how those charges change. So if we look right here, above iron, iron is by itself. Any element in its uncombined natural state is 0. So above iron, I would put a 0. Here, oxygen's always -2. There are 4 of them. Okay, so that's a total of -8. But we really don't care about that, because if you notice, sulfate stays the same on both sides. So what we really care about is that sulfate as an ion, SO4, is -2. So what did copper have to be? Well, it had to be +2. Same idea on the other side here with iron. If you notice, iron is with sulfate now. Sulfate is -2, which means iron had to be +2. And now copper's by itself, so it is 0. If you wanted to, you would write this down. Iron goes from 0 charge to +2 charge. Copper goes from +2 charge to 0 charge. So here's where it gets tricky, because you have to remember that electrons are negative. So for iron, to go from 0 to +2, what had to happen to it? Well, it lost electrons. So iron loses electrons and therefore is oxidized. So iron goes from 0 on the left to +2 on the right. That means it lost two negatively charged things and therefore was oxidized. That also makes it the reducing agent. Remember, whoever was oxidized is the reducing agent. On the other hand, copper goes from +2 to 0. It became less positive, which means it gained electrons. So copper gained electrons to go from +2 to 0, so it was reduced and therefore makes it the oxidizing agent. Same deal here. I would write this down. It's a big, long equation. That's one thing you'll notice is a pretty common thing in redox reactions is they tend to get a lot more complicated and long. There is a way to balance redox. It's kind of a pain. We're not going to do that today. It'll take a while. We may do that at the very, very end of the year's balance redox reactions. But here we go. You can go ahead and pause. If you haven't paused already, do it and write this down. But I'm going to go a little bit faster now. Okay, copper. We're pretty sure here copper is +2 and sulfur is -2. That would be normally what you think. So we'll just leave that way for now. Hydrogen's always +1. Oxygen's always -2. This is a -6 charge, making nitrogen +5. So nitrogen here is +5. Here's that sulfate thing again. This is -2 total, which means copper's got to be +2. But here we have to figure out sulfur. Well, this is +2 above copper. Oxygen's -2. That's a -8 charge. So sulfur is +6. So I'm just telling you right now, we went from sulfur was -2 to sulfur of +6. That's a big change. Okay? Keep that in mind. Here, nitrogen and oxygen. We know oxygen's -2. Nitrogen's got to be +2. And hydrogen, oxygen never change, so we can ignore water. You can always ignore water. Hydrogen, oxygen never change. All right, so let's go back and look. Nitrogen went from +5 here to +2. To go from +5 to +2, it had to gain electrons. So it was reduced. Nitrogen went from +5 to +2. It became less positive. Nitrogen was reduced, therefore making it the oxidizing agent. Sulfur, on the other hand, went from -2 to +6. From -2 to +6. So it lost electrons. It lost a lot of electrons, 8 actually, to go from -2 to +6. And therefore it was oxidized, which makes it the reducing agent. So you could just write it out down here. Nitrogen was reduced and therefore is the oxidizing agent. Sulfur was oxidized and therefore is the reducing agent. Same kind of problem, and I'm going to leave this one for you to figure out, all right? But the idea is to go through, give everybody their charges, all right? Give everybody their charges. If you can't do the oxidation states from the last E-day, this is going to kind of hurt you now. Once you've done all the charges, whoever gains electrons was reduced. Whoever loses electrons was oxidized. The one thing you got to be careful about, electrons are negative. So if you gain electrons, in other words, if you were reduced, you become more negative or less positive, depending on what the starting charge was. On the other hand, oxidation, they're going to lose electrons. So if you lose electrons, you get more positive or less negative. And then again, whoever was oxidized was the reducing agent. Okay? Real quick, again, in Blackboard, units and lessons, E-days. Okay, you are now going to be doing E-day 2. E-day 2 will have an attachment, which is not up there yet, but you'll have an attachment on here. That's going to be your assessment. You have two options for turning that in. Print it, bring it to your teacher, enter the answers in the test submission tab. There you go. These office hours aren't quite right either. But hopefully this helped you. If you need anything else, let us know. And again, there's another video where a guy's writing. Now, the only thing he doesn't include is he doesn't use the terms oxidizing and reducing agent, but I think I've told you that enough.